with that, I'll turn it over to Art.
Good afternoon. My name is Art Khan. I am CEO of Aveopt, and we're very pleased to be here. What we want to do today is provide you again with some insight into what Aveopt is about, the technologies that we're interested in, some of the initiatives that we're now working on, and how that might translate into a collaborative effort between Michigan State University and our organization. So with that, a little bit of who we are. What we've done is we've literally developed a platform, we're a platform company, and we've developed that platform with the idea of focusing on information management, which we view as having three primary pillars, that being data information acquisition, the synthesis or analysis of that data, and then the dissemination or communication of that information. Again, we view those as three key components of information management. What our platform has done is pull all of those three pillars together and integrate them, and we have done so in a manner where we are focusing primarily on the industrial base and the needs that they have, and that industrial base could include infrastructure markets like telecommunication, transportation, energy, oil and gas. We also have applications that we're looking at and initiatives that I'll talk about a little bit later relative to agriculture as an example. So any major industry that requires the acquisition, synthesis, and communication and dissemination of information is where we're headed and what we're working on right now. Give you some examples. We've integrated sensor packages of various types with various types of technologies associated with them. We've looked at taking those packages and deploying them for data acquisition, and we can deploy them either on UAVs or UASs. We can deploy them on ground vehicles. We can deploy them on stationary systems. Our end of it is the platform that you see below, which consists of sensor packages, navigation, computers, and communication. And then driving all of that, driving that platform is the software that we have underlying. And that includes software not just to distinguish between the various functions, but also the software that allows us to do synthesis and analysis and the analytics associated with it. We have tied these packages together, and we've added in other technologies such as the augmented and virtual reality solutions that are available in the marketplace, because again, we felt that this adds a dimension to what we're able to provide to that industry. So as an example, we're using augmented reality for the telecommunications sector, wherein they have a requirement to identify where they might want to place a second or a third cell tower. And they need to have basically a clear line of sight between those two towers. But those towers are miles apart. Right now, they typically send up two teams, okay, at the proposed site and at the site that they're at. And that turns into a rather expensive and resource-intensive type of function. And so as a result of that, we came up with an augmented reality solution where we are effectively creating a virtual tower X number of miles away. So we can do the same process in minutes, and it takes them hours, and we can do it with just one team as opposed to sending up multiple teams. So those are the kinds of things where we see these kinds of technologies being able to be applied in a manner that provides significant value add. A little bit about us. We were founded in January 2016. Our headquarters are in Traverse City, Michigan, and that is also where we do our manufacturing and assembly of our systems. And we also have an 80-acre proving ground that we utilize for product development that we are working on, as well as looking at it from the perspective of the UAS aspect, because, again, much of our systems are delivered via drone or via UAS or ground vehicle or autonomous vehicle. So that proving ground is also there to do various types of development, testing, and so forth relative to the UAS environment as it relates. We have with us Jim Mikowski and Melinda Marion. They are from Michigan Unmanned Aerial Systems Consortium. Aveopt is a member of that consortium, and as such, that 80-acre proving ground falls under the auspices or the authority of MUASC, and in particular, New Air Alliance, which is an FAA-certified test range. What that does for us, it allows us to literally do drone or UAS testing in accordance with being compliant with an FAA certified test range. Therefore, we're allowed to do a lot broader type of testing. We're not necessarily limited by a 400-foot ceiling that you always hear about, and so forth. We can go significantly higher. If you have questions or you want more detailed information about MUASC, Jim and Marion are sitting in the back, and I'm sure you guys will be glad to answer any questions. Absolutely. Right. Okay, so we are also affiliated on the academic side with University of Michigan. I had to say it, plus that's just what it is. And we have Northwest Michigan College, who has the 9th or 10th largest drone school in the country. Northwest Michigan is located up in Traverse City as well. On the industry side, we're associated with those particular industry associations, again, because of who we serve, who we're trying to support in terms of the technology that we have. Industry partnerships, we have Atlas Space, and we'll be hearing from Mike a little bit later on what Atlas Space is about and their capabilities. UAV America happens to be one particular drone company. Samsung, I guess you know who they are, as well as Microsoft, and Esri. Everybody familiar with Esri or not? Esri is kind of like the 800-pound gorilla in the GIS community. And so we work with them closely in terms of evolving GIS technologies as we use it in our applications. Okay, key technologies that we are playing with, that we have applied within our system, include those that you see listed there. And if you think about it, most of those are actually or have been identified as the disruptive technologies that people expect to be seeing and working with over the next 10 years or so. And what we've seen is the ability or the application for those technologies to be played in the world or the environment that we've been describing. Again, dealing with applications that allow us to support the infrastructure or industrial base of the country. What we also see emerging that we are beginning to get into is blockchain, simply because part of the critical elements that we deal with in terms of IoT or big data is the ability for us to interface and integrate with other systems, other databases, and the like. And much of what that interaction would be of a transactional type. And so being able to do that with blockchain, we see as a step forward as part of our roadmap. The solutions that we've developed, and again, as I indicated to you before, we have, as an example, a single platform, TerraPosition Pro, that literally has all of those individual applications, those individual solutions. And these particular solutions, while appropriate as an example for telecom, what we have found is that same single platform is also appropriate for transportation, for energy, oil and gas, and so on. So what we have here is a single platform that really covers the spectrum of the infrastructure markets as well as other industrial segments such as agriculture. Okay, again, examples of some of the sectors that we're dealing with. You can see that what we're doing here is applying these types of technologies. All of these technologies are important to us. Quite frankly, in some instances, I would rather collaborate with a group that has a significant play in some of these technologies as opposed to starting from scratch. That's not where we want to be at this point. We'd rather be hitting the ground running. So those are the areas that we are interested in. That is what we're working as we move forward. In terms of the initiative associated with UAS and UAV segment, we are looking heavily at the utilization of satellite technology, okay, and that's one of the reasons why we've been working with Atlas Space to address the issue of unmanned traffic management as an example. Right now, people are looking at it in the context of vehicle to vehicle or vehicle to infrastructure. We believe that there might be a third alternative, and that's one of the things that we're looking at playing with. Now, those are the technologies we are working with. At the same time, we have that 80-acre proving ground, which allows us to do a great deal of the testing and development associated with that. So as an example, beyond line of sight, we have Consumers Energy has a string of power lines that we are going to use. We've initiated some discussion with them so that we can utilize those power lines to further evolve the beyond line of sight capabilities. Again, that being critical. As everybody knows, I mean, right now people are concerned about latency issues and things of that nature. We're looking at alternatives to that approach based upon utilization of sensors both on the drone and on the infrastructure, as an example, that we're looking to inspect or view. That same system is also used for public safety, search and rescue, border patrol. We are able to literally target something in a distance. We can geotag it, and we can then move on to the next targeting function. The value there is, if you can imagine search and rescue where you see the pictures of people standing on the rooftops, waving for help and all of that, and you see a drone actually going there and identifying those people, that drone literally has to get there so that it can give the accurate coordinates of where they are, okay, before they can transmit it back. What we can do is literally stand off, whether we're talking quarter mile, half mile, mile, or more, and target those groups, geotag them, know where they are, and communicate it, and move on to identify the next target. So what you have there is a situation where that kind of technology is actually saving time, which is absolutely critical when you're dealing with search and rescue. By the same point, Border Patrol, groups like DHS are looking at it in terms of how can we not only do search and rescue, but also do targeting relative to patrol, and begin to apply other types of technologies such as AI or predictive modeling in terms of taking in various types of data sets, such as the terrain that's there and other types of issues, and deal with it in terms of where might the next appropriate direction be that that particular target might take, and so on. What that allows you to do is limit the number of resources that you have to use in order to solve that issue. Yeah. I've been talking a little bit about agriculture. We have an initiative right now up in Traverse City that we are working toward, which is basically within the wine industry, vineyards, where we are looking at using sensors basically deployed via autonomous ground vehicle to be able to basically go through the vineyard, acquiring information and data relative to the state as to where the grapes are, the soil, etc. And based on that, go through an analytics function and come up with recommendations. Now, at the same time, we're also working with Atlas Space, because as part of that whole initiative, what we really want to do is combine the data that we can acquire from the ground system with the imagery that could be provided and the sensors and analysis that could be provided from the satellite community. So that, again, what we're putting together is a solution that is representative of the most information and data that we can acquire and then therefore analyze. That's just conceptual right now. I can tell you that the laser, continuum laser, has already been developed. What we're working on now are the issues associated with some of the analytics, measurement capabilities, and things of that nature. And then looking for the appropriate autonomous vehicle that we can put that on. Okay? So that is what's happening right now. Lastly, as I indicated, we're working with Atlas Space to, again, integrate the information and the data that becomes available to us through satellite technology with the information that we are acquiring on the ground, enabling us to do collaborative engineering, again, through satellite communication, as well as doing the unknown traffic, as I talked about before, and other things like asset management, which is particularly important right now, not just in terms of the infrastructure market, but in terms of many of the other markets, including autonomous vehicles, as an example, knowing what's where, when, and so on and so forth. So these are the things that we're working toward. There's the contact information. I'm going to cut my end short so that Mike can go. And at the end of all of this, we'll certainly entertain questions. Tim will also be speaking after Mike He's going to give you much more detail on that proving ground relative to what's there.
Thanks, Art. Are you driving or am I driving?
You can drive.
I don't have a license. All right. So my name is Mike Carey. I'm one of the founders of Atlas Space Operations, and I'm currently in the position of Chief Strategy Officer. I've learned that's what they do with people who are replaced by smarter, younger people. They put me in a place to think big thoughts and connect people together to grow the business. And I'm very excited to be here with my Aveopt partners at Michigan State University. It's my first time ever on campus, and boy, have I been missing a lot. This is awesome. Thanks for joining us today, and I hope that we have a fruitful collaboration afterwards and can actually produce a partnership, or maybe several partnerships, that produce technology, knowledge, and business opportunities, quite frankly. So Atlas Space Operations provides a service for satellite owner-operators. Spacecraft are really cool. They're kind of expensive, and rockets are even more expensive. But once the satellite gets in orbit, you have to communicate with it. And there was a period of time from 1957 to about 1970 where space was pretty much the domain of nation states, right? So the Union, United States, Cold War, India, countries put spacecraft on orbit. Then became big telecommunications, right? Remember, some older people might remember along the television footer it said via satellite, and that was kind of cool. This information was being broadcast across the globe by way of satellite. Well, now that's just kind of between that and submarine cable, is undersea cable. Information is information, and it's all over it's accessible all over the globe. It wasn't until the 90s where companies like Teledesic, Iridium started populating low Earth orbits with commercial spacecraft. Still remarkably expensive, not profitable. But in the last few years, we've seen a dramatic change in the marketplace. There's a 500% growth of spacecraft on orbit, 500% growth of satellites on orbit, exhibited and predicted. In 2013, I think there's 34 satellites went on orbit globally, 34. In February of last year, over 100 went up one rocket. In September of this year, 90 go up one rocket. So in 1 year, one rocket, more satellites than the preceding 3 years together. Now, are the spacecraft the same size, same sophistication, same purpose? No, they're not. But it's indicative of where technology is taking us. If you take that large population growth on orbit and you put it into a traditional solution where satellites have to go through a series of antennas, a series of players, a series of people, things go slow, they get bogged down, and they're expensive because of the overhead. Atlas has actually eliminated this data bottleneck by innovating what an antenna or an aperture looks like. Instead of a large parabolic dish antenna, we've created what we call Atlas Links. It's an electronically steered array, it weighs about 50 pounds. And we're on a contract with NASA right now. We work at Goddard Space Flight Center and flight facility at Wallops Island, Virginia, to demonstrate this technology and its applicability to recapitalizing the NASA Near Earth Network and potentially their deep space network. This was actually created to solve a lunar problem. But what we found is when you're not talking to deep space with 20 of these, 4 of these replaces a 6-meter dish antenna. Meaning instead of spending $1 million on infrastructure, you can spend about 20% on infrastructure, and the rest of it goes into your spacecraft and your data. It goes into the cloud. Amazon Web Services is what we prefer to use at this time. And from there to you through our proprietary software, which not only manages the space platform, spacecraft scheduling, antenna scheduling and all the configuration of the radios, if you will, but also it's a place to warehouse and do analysis on your data. We're a global company, although we're headquartered in Traverse City, Michigan. We operate in Soronquila, Finland, Sunyani, Ghana. That's us working hard in Traverse City, and Invercargill, New Zealand. We also have a station coming up live in August for one of the largest satellite building companies in the world, Space Systems Loral. Will be operational for them in Albuquerque, Mojave, California, Rooster, Washington. For NOAA, National Oceanographic and Atmospheric Administration, in Ghana, but also in the Seychelles and in Tahiti. So if you're looking for world travel, that's something that we do. We have 17 sites, warm or hot. We have 23 planned for the next 2 years and access to 44 globally. This highlights a near-term, if you will, a now/near-term chart of our activities. This is ours. This is ours plus cooperative. We have several in the United States. And then the number, American soil has been changed to Tahiti. Guam and Japan will be operational at the end of the year. There's a couple not shown here because it's a dynamic. It will be we're working with the National Science Foundation to get the McMurdo Station in Antarctica, hopefully by 2020, but 2021 at the latest. They're actually rebuilding the town, so getting space on the very few aircraft that go there, relatively speaking, is challenging. We do share other people's antennas, so if we have our own, but we're very open to using other people's apertures. If Michigan State has antennas that they'd like to collaborate and bring onto our network for dual use or mutual use, we can certainly discuss that as well. So antenna technology, communications technology, and data are really what Atlas is about. And so just a quick story on our Atlas links, which I mentioned is our electronically steered array. This was an artist's concept in 2016. It was an idea. This is Hannah is our mathematician from Eastern Michigan University. She does our orbital analysis. And this is what Atlas links looked like in 2017. And this is what it looks like maybe 2 months ago in Virginia when we were testing it with NASA. What you're seeing is the evolution of an idea to reality, to refinement, and this will be fielded in August, operationally in the field. So at other places. So instead of us putting up a monolithic antenna on a big pedestal poured in concrete, 40, 50 pounds, 2 of us could put a field of them together in a couple hours, 5 cables, it's all math. It's all passive, there's no RF transmission, so you can't command a spacecraft. But in the satellite industry, typically you receive at least 4 times as much as you transmit. Hence, you don't need to have a transmitter every place on the world, but you do need to have receivers as many places as possible. So I mentioned that we're working with NASA. We have an ACO, a collaborative opportunity, which is a contract. It's a non-cash contract, but the exchange of resources and availability of their engineers and engineering facilities is valued at about $14 million. We have a CRADA with the Air Force that allows us access to spectrum as well as hardware and analysis. All of this is regarding our software applications as well as our data flow, and in addition to our antenna technology. We're a diverse group. We formed the curling team this year to do team building. So Yunajit Dasgupta is from the Bengali part of India. Miguel Acasuso is Mexican from south of Mexico City. We found both of them in Michigan. She's a local girl from Traverse City, Santa Monica. I was born in Grosse Pointe, but had 21 homes in the Air Force, retired after 32 years. Meant to stop at 20, but I forgot. Mm-hmm. Mark Malos is our COO. We hired him out of GoGo Air from Chicago, but he's also a Michigan I must have been on time. Well, there we go. That concludes my briefing, my presentation. I look forward to future questions. Atlas is an innovative group. We started in 2014, and we've gone through a couple funding rounds. We have another one coming up. We're operational contracts again with NOAA, NASA, Air Force, Space Systems Around, Black Sky Global, Space Flight Industries out of Seattle. So we went in for a small satellite business, and what we found was bigger business was hungry. They had the appetite for innovation. And so with the exception of me and a couple others, we're a very young, dynamic company. We travel the world, but we're local. And we want to bring opportunity to Michigan State researchers so we can move forward both in the advancement of communication technology, computational capabilities, and then working with our partners, Aveopt. How do you bring the air and space layer together in a ubiquitous way to take full advantage of those mediums, both for defense, civil, agriculture, all of the different applications of the technology to the betterment, even medical and med tech and fintech as well. So, but predominantly reinforcing our relationship at the test center, the test location up in Cedar, Michigan. We had the opportunity to play very actively. We've already filed for licenses, just sent a letter off yesterday. I believe that we'll have what we need from the space side to match very, very nicely what the Aveopt team has in the drone community. So, thanks. Okay. Good job.
So my name is Tim Nash. We're talking about our proving ground where we do all of our testing, and Atlas is there as well doing their testing. Why Cedar, Michigan, which is right outside of Traverse City, by the way, for those who don't know. Well, I'll give you a little history about myself. I was the industrial liaison at U of M, and I can remember going to the director of the facility at WIMS and saying, yeah, I know some technology groups up there in Traverse City. Let's make some numbers out of them. And they'd be like, oh, I thought there were just cherry farmers and some tourist groups up there. I'm like, no, I'm sure you that. So I brought back a membership from there, Microline Technologies. So they started to believe me a little bit. Some summation of that story is that they are so focused, U of M is so focused on Detroit, Ann Arbor, and Flint, they really don't want to move out of their comfort zone too much. And when I met up with Michigan State University, they have a passion to go all over the state of Michigan. And so that made it very easy for us to take this route here to MSU. And I'm really, really love with the reception that we got today. It was amazing. So after I left U of M, I went and worked for a small drone company related to Lockheed Martin as their sensor engineer. And I got to working with some of the customers there, knowing what the industry wants. And so I was at a conference, and I was chatting with one of Samsung's developers, and I made mention of first-person view. And this is before first-person view came out for racing. And next thing I know, 2 weeks later, I got an email from them and saying, hey, can you show us? I knew first-person view is going to be trivial, as you all know. Why not add some sensors on there so you can do some engineering inspections? So I did so. And then that whole package with the VR goggles went out all over the United States. And so right at that point, we located our headquarters not in Traverse City, but in Ann Arbor, Spark. And so one of the challenges around that area, though, is finding some test areas, not a farm field, that you can leave your equipment at, for calibration reasons. And that was really the difficult problem, was finding somewhere, that we can keep our stuff, not tear it down all the time, not put it back up, So I had this facility, had this land up in Traverse City. I said, why don't we just go up there and, build a little shack and, work off that. So we did. And that's when I was up there and working with the VR and developing some of the sensor payloads. And there was a virtual reality demonstration at the Indigo Hotel. And I just heard of it the same day. And I said, well, wait a minute, I'm Mr. VR in this area. Why don't I go over there? So I did. I happened to be wearing my University of Michigan engineering t-shirt. I didn't know that it was sponsored by Michigan State University. It was all a sea of green and white. I walk in, I'm the only guy, and I walk in, Luann Simons is right there, your former president. And all of a sudden, snapshots and pictures are taken. And I made sure that, I said, this is not a competition. I didn't know that you were sponsoring it. I didn't come here to destroy, your game plan. And we kind of hit it off a little bit. So just recently, I contacted her again. And I didn't know if she remembered me at the time. But at the table, Mike was there and Art was there. And we just started talking about how can we connect to Michigan State University. We have this awesome facility outside of town, which I think can really benefit some research projects. And so we started talking, I started to introduce everybody at the table. And I said, Luann, I don't know if you know who I am. And she said, oh, I know who you are. And so yeah, that's how that conversation started. So anyway, here we are in Cedar, Michigan. And we have an 80-acre facility, but the 80 acres stretches almost a mile. And it's not surrounded by any houses or developments. And so we have this whole area to work with. And most of this area up here is state land. And we have Aveopt Conservancy over here. And then we started just building some structures over down here by the road. And there's a barn that we can use that's completely empty where Atlas Space is going to just set up a lot of the test equipment, oscilloscopes, and RF signal
generators, modems,
fun stuff. So here's an old plot map that I was just get an idea. Here's the front of the property. You get a river that goes through it, but we have an easement that goes all the way back here to the next section. And then you have all the state land here, and all this right now is Aveopt Conservancy. And we have permission to fly over all this area right here, right now. So it makes it a unique situation just by the length of the land and the size of it, and nobody being around it. So on our facility for Aveopt, we built a cell tower and some consumer power lines that we can do practice doing audits with our sensor payloads, which is a big thing for the broadband rollout to rural areas. This is where they're tacking on fiber to telephone poles, and they have to do audits on every single pole in the United States if the states adopt it. So we've been doing utility pole inspections. We have some utility poles and some of that infrastructure there for transformers. So we can look at transformers for the other sensors. We have a lit helipad for, we were thinking that we were going to get some waivers down the road for flying at night maybe, but I don't know, I thought it was just cool to have anyway. So the future, we're going to have Atlas Space's arrays on there in the field next to us. And so that's going to be a very interesting relationship between the two of us right there in the same place, where we could work together on different projects and really push the boundaries on the technology. So Atlas is going to be moving into the barn here and working out of there 5 days a week probably. They are going to be testing their Ops Center interface. We have a variety of different customers. So with a variety of different customers, they all use different software. They all have different packages. So Atlas is using what's called the Freedom Link. And so we got to make sure it's going to interact with all their customers well. So they're going to be working on that out there. Of course, design and test infrastructure. They're going to have an operational UHF site, which means tracking aircraft and some other projects that they have. The Links test site, satellite telemetry, tracking, and control is what the TTMC stands for. Passive surveillance. So one thing that we can do for Atlas is fly some drones around and see if they can track us. And then we're out to make some software that hides from them, maybe. And then telemetry. What I mean by that is that's their main thing, getting data down from satellites. And so that we're going to be looking at new gear that's going to be working, helping them enhance their product, and just looking at software that's going to be helping the telemetry get there quicker. I know Art mentioned that we have the MEOAS CSAPA, which is the Michigan Unmanned Aerial Systems Consortium. They are kind of the nonprofit organization from the state of Michigan that has got control of the Alpena site. And so through them and a COA that is from the state of New York, from Drone Alley, it is we are working on getting some of the cool things extended to us from the waiver that they have, which is flying at 1200 AGL, out of line of sight, and at night. I get to use my helipad. So, and that's about it for me. Is there any questions? Right.
Well, let me
Yeah, sure.
break the ice.
Yeah.
Both you and I have talked about a lot of things, a lot of activities. How big a company is it and how real are these? I mean, a lot of these seem to be planned.
Well, a lot of
planned in the future. I looked at your company in the LinkedIn and it lists 3, I think, or 4 employees. That's an awfully small number
Right,
of people to deal with so many things. How big is the company?
Well,
What's your turnover? What?
sure. We're
How
starting. We
How
started.
real are you?
We started in 2016, and we have six people working with us right now. We created a single platform with an ARM processor on board, so we can automate software. But the key thing that we try to push is a single payload, single sensor package that does multiple things, so you don't have to have a whole bunch of people initially. As far as contracts, we have a couple contracts, small, but we're still trying to break the ice out there. But we still look at bringing on researchers like yourself or anybody to work with and maybe develop some new stuff.
If I may, again, as Tim said, we're a startup, and with that comes a lot of pain, okay? Because there's the issues associated with all people willing to adopt or accept new technology. Usually a lot of, in the industry, like say, it sounds really good, sounds great, but they don't wait till he buys it first, right? So Jeffrey Moore, crossing the chasm, that kind of thing. In 25 years, it's still the same issues that you have to deal with their technology. So as Tim indicated, we've developed these systems. We have some contracts now, okay? And what is happening right now is the receptivity that we're getting and the acceptance in the industry as reflected in things such as we were just awarded the 2018 Telecom Innovative Technology Company of the Year for the telecom industry, and that came out of TNT Magazine. We've just been identified just this past week by CIO Application Magazine, which is part of the IDG group. I don't know if you're familiar with them, but they are one of the largest market research companies actually in the country and globally. And so we've been identified by them as being one of the top 10 companies in terms of applying technologies integrated in a fashion with UAV, UAS systems and things of that nature. So what we're seeing is we're beginning to see that type of adoption. We're beginning to see companies that are significant in size, such as AT&T, now talking to us about wanting to get together for pilot programs to further what they see or envision as the technology movement. So that's what's happening at this point.
So in our case, we have 16 full-time employees. We 20 when you consider part-time, not including 1099. We had the opportunity to let 2 people go. So we know what the HR process goes through. We follow ITAR, EAR, FCC, and FAA regulations and coordination. We have contracts with the U.S. government, both civil and military. We're a multi-million-dollar company and not profitable yet. We anticipate that to be this year, and we expect to be independently valid or valued at over $20 million by the end of this year. And we were named a Morgan Stanley Top 12 Innovator for 2017.
And you know what you said about not being able to sell technology. I worked for General Motors Research for a very long time, and we had exactly the same problem. We invented something and said, well, wait till somebody else does it.
Yeah,
So-
it's the old, I've been digging this hole with this shovel for the past 25 years. Why do I need a shovel?
So in the space industry, we are the most calcified industry in the world.
Right.
You would think space, very innovative, very risk. Let's go do it. Most risk-averse people in the world, because once a spacecraft gets on orbit, you don't get to touch it again. So don't touch anything. It's working, don't touch anything. So we've innovated the space for antenna and command and control software. And we found a partner in Aveopt that is innovative and real. So people don't want to take a risk, still don't want to take a risk. The government is subsidizing your risk, essentially, if you're a new space company. But OneWeb wants to put up 900 spacecraft, right? The gentleman in charge of their ground system, he and I both reported for duty at Offutt Air Force Base on the same day to fly the same satellite for the next 3 years on the same crew. And we've been friends ever since. His company, he evaluated us and said, wow, that's great stuff what you're doing, but you're too new. I said, I'm too new? Maybe the last time someone put 900 satellites on orbit. That's a little new. So they want to mitigate their risk by going with a traditional effort. So they're going to spend $500 million in traditional antennas. That's crazy thinking to me. These guys here are innovative. When Tim and I met, it was like, it started with how do we do land sharing? And I'm like, wow, what do you do? I know all kinds of drone people that need stuff that we've got. And this became a speed dating thing, and it just one idea comes after another, and focusing becomes the challenge, right? Focus on a target and a deliverable, because there's so many opportunities out there. And what we're finding, and you'll find soon, is that once you get that harmonic nailed, it's like you get the flywheel effect going, and then it goes crazy, and we're having a great time.
You got to kind of look down the road, right? You kind of have to look at it in the context of a couple of things. Number one, which markets and which industries are willing to take that first step. Okay? There are those that are just that aggressive because they see benefits to be had to their bottom line. They're looking at it from a business perspective. Okay, you're going to have those that are key industries to target because there's no choice. It's a mandate, or the adoption of certain technologies has become so ubiquitous, such as drone technology. Right? I mean, everybody is adopting drone technology. Everybody wants a drone. Okay, well now who's going to deal with unmanned traffic management? How is that going to happen? Right? Those are the technologies that you want to look at relative to where the industries are going, so that you can be that individual that provides that type of solution. For those companies that are aggressive and looking at their bottom lines, those are the ones that are going to look at what can a new solution, what can a new technology applied in a particular fashion do for me on my bottom line. Is it going to reduce cost? Is it going to accelerate my time to revenue? All of those things are the things that you have to look at. And it's not easy. I mean, more small companies start off in direction A, and before they're done, they've gone through 5 or 6 other directions, okay, just because that's the dynamics of it. Fortunately for us, what we have found over the past 2.5 years is we have found those industries that are willing to adopt these technologies, or beginning to, based on either their business model that they've got, or they're looking at because they see the fact that they really have no choice.
We've found that precision ag companies are very interested in our offerings because gathering the data in situ is, it's not a new thing, but leveraging small spacecraft or drones that can collect the data differently, more and aggregate it more readily, and then how do you get it back? How do you get back to home station? And in some environments, it's very simple, but in more austere rural environments, it's remarkably challenging, just because of the distance, the distance in R squared on the signal strength. And what we found is we've got customers in Canada, Australia, and Georgia who are all about IoT precision ag, and that's how we got their business. And we think that Michigan State, with the expertise that you bring, that this would be a match made in heaven. And New Zealand's also, on our partner list. But you guys are super strong, and we'd like to find opportunities to work with them.
So are you looking to plant some crops on your 80 acres?
We could do that. I thought about doing that already. We do have adjacent partners, farmland that's adjacent that we can utilize as well. And we have vineyards we've already been working with for our ground vehicle. So
I only have 4 acres.
is that,
The prototype you showed earlier, or vineyards, could that be adapted to other crops? You have,
yeah, actually, yeah, it could be. I mean, all in that case, you're talking about a mass spectrometer, so you just got to create the data, the data files, and what you're looking for.
So tomatoes or hops?
It doesn't matter.
Okay.
Yeah.
I grow hops.
Yeah, in that picture, it was the ground vehicle was just in theory, it's a desktop model at this point. So the super continuum laser is existent. The ground vehicle has not been chosen, but that ground vehicle did make a little bit of sense because it straddles the rows nicely, and you can get the scans on both sides. Any other questions? All right.
Is there anybody here interested in multispectral or hyperspectral
You are?
in general or in specific application?
I'm in plant science.
Plant science? I was asked specifically by a JPL colleague of mine to try to find a hyperspectral interest in Michigan specifically. And so I'm actively pursuing that. And I have a colleague who has a startup company, 1-year-old hyperspectral in San Francisco, HyperQs. But more importantly, this gentleman is a seasoned principal investigator at JPL. So if that's something you'd like to pursue afterwards, I'd be glad to talk to you about that.
Drone people in there. Not so much. Sorry, Jim.
join me in thanking our speakers.
Yeah.